Yeah. So
Thank you.
welcome
Thank you,
Vivek.
Vivek.
So of yeah. So our first session on Kubernetes overview. So this is a I mean this is a we had to understand from the basics, and then we can move to the actual practical session, which will be more
Okay.
interesting.
How are we going to do the practical
But
session? Is it
uh,
through T-Mobile? T-Mobile or
yeah, you have to do with
is
me.
it T-Mobile or we
You
have
have to,
Reliance resources?
yeah, you have to. Uh, I think we have to use our own. Better to use our own. Why to?
Okay.
Yeah. So basically, so this is basically what Kubernetes structure is. Basically, Kubernetes. We need to know what is. We are focusing on Kubernetes for the
Mm-hmm.
containerized applications. Okay, and we have in Kubernetes we have one is Kubernetes Master, and all
Uh-huh.
these are worker nodes. So this is a pretty basic. Why I'm not able to go ahead?
Yeah. Press F5.
Yeah, so I'm able to move ahead now. So basically, Kubernetes, what it does is it deploys
Mm-hmm.
the apps, the containerized
Uh-huh.
apps. So if you see in this diagram, all these are containerized apps. So basically, we have an app. App means any program, any Java program or any
Mm-hmm.
.NET program, anything whatever we do, we we deploy it to the Kubernetes and
Okay.
using containerized apps. So we have to understand like the note is here like Kubernetes is entirely content. All these terminologies are little important, so that is why I'm little stressing on these things. So basically, Kubernetes is a
Yeah.
container-centric management platform. So basically, Kubernetes works at the container level
Mm-hmm.
and not at the hardware level. So, so if you see any AWS machines or Azure machines and nodes, it doesn't work on the hardware.
Mm-hmm.
It works on the container. So, so that is the reason we should be mindful that this is a
Mm-hmm.
container-centric management platform. So this is one key point here. So the other thing here is so basically the important thing to note here is it is decoupled to host operating system. So what it means is like uh, we don't care about like Kubernetes don't care about whether the system is Windows or Apple MacBook or Linux machine or so on or so forth, whatever machines you can think of. So all it
Mm-hmm.
cares is about the containers. So basically, traditionally, if you see in our other traditionally we need to have libraries installed, and then we can deploy our stuff
Yeah.
into those environments. But with Kubernetes, we don't have to be
Okay.
worried about
Okay.
the libraries or anything. So, so this is one of the point which we should take care. I mean, as a takeaway, like they are decoupled
Okay.
from the host operating system. Now, how Kubernetes basically Kubernetes what it does is basically it orchestrates the containerized workload basically and the required infrastructure. So basically, it deploys in a cluster of machines and it uses everything. It uses REST APIs like it uses REST APIs to talk to these uh, individual machines like
Mm-hmm.
worker nodes. We'll see it later
Mm-hmm.
what is a worker node and what is a master node. So we will see later
Mm-hmm.
what are those. So yeah, just be mindful about these terminologies. And so basically Kubernetes this K8 is a
Okay.
short acronym for Kubernetes. So that is the reason I have written here everywhere K8 K8. So so this is a this so basically this is a Kubernetes master in the center if you see
Okay.
here, and these are all node machines. So basically this master controls all these
Mm-hmm.
nodes. So every cluster will have one master node and we'll have like one, at least a one worker node or a multiple worker nodes. It depends on the configuration
Okay.
which we do. So basically, a node is nothing but a VM or any physical computer. So
Yeah.
most of the times we hear about VMs and not about physical computers, but we can do
Okay.
at the physical computer as well. So that's more that's more labor intensive actually. So and so what else? These are all like
Okay.
master node manages all the cluster nodes and coordinates all the cluster.
Yeah,
I
yeah.
mean, we
Like,
know all these
yeah.
things, so we don't
You
have to go
with
through.
your knowledge sharing. Yeah.
Yeah. No, I'm just saying that you already know this, so that is I'm not talking about me. So
Yeah. It's
I'm
a work
learning from you,
experience
so
that
we
you.
don't have to worry about those.
Okay.
So, and the important thing here is like master node is responsible for
What
scheduling
does
the
the pod
pods.
mean?
Like basically, a pod is nothing. Yeah, pod is basically a group
Pod,
of
a group of
containers.
containers. Okay.
So when we yes, so basically, container is an app, and when we have a group of those apps, those are
Okay.
called as
Let's say
pods.
if you have a multiple
So
service, those are called pods.
so
Like multiple
yes,
containers. Say one
yes,
container
yeah,
has a service or application API service for the what do you call dick service or the math service. Those are different service. Those are all forms of pod. Okay.
yes,
Okay. Oh,
pod, yes, yeah.
so simple.
So yeah, yeah. See, everything is simple for you, man. You just have to touch like a Midas
Okay.
touch. You have to just touch it. Yeah. So so the actually what are worker nodes? So we talked about master nodes. So the worker node is basically those are the actual machines which bear the load of application. So the application it gets executed at these nodes at these machines. So basically they actually
Mm-hmm.
do all these nodes will require Docker to be installed. And we will see later. We don't have to we don't have to manually install Docker
Okay.
on each of these machines because once we have Kubernetes installed, Kubernetes manages all the Docker container installation. But we need to be mindful that if you see in this diagram, each node has one kubelet and one Docker, one kubelet and one Docker, one kubelet and one Docker. So basically, if you want to if you want to
Mm-hmm.
introduce any node to a cluster, then we need to have a we need to have a kubelet and a Docker instance
Okay.
running into that machine. So then only that can be introduced to the Kubernetes master, Kubernetes
Okay. Okay.
cluster
Okay.
actually. A- And yeah, so Docker handles all the container operations. So basically, if your API is doing some addition or subtraction or returning any functional function value, or it is doing any calculations, like whatever it is doing, whatever your API is doing, that is handled by the Docker. So basically, the logic of your program
Mm-hmm.
is being handled by the Docker inside the worker node. So Kubernetes doesn't care about
Okay.
that. Kubernetes Docker cares about it. I mean, what is the functionality which is going on?
Okay.
Uh, yeah, and what is a kubelet? Kubelet is nothing but an agent program that may actually that has to be there at the node, and yeah.
It's more of
So that
similar to it as
so that
like it sends the information to master Kubernetes
yes, yes, for the
or
API, it's like an
yeah, yeah. Similarly,
API
when you
mesh
have all
network.
the
Yeah.
worker nodes, like if we have a Sumo Logic, if we need anything from Sumo Logic, we might need the Sumo Logic connector installed on all
Yeah,
the nodes.
and
Okay.
connector. Yes. So
Okay.
like that, we have to have a kubelet
Oh, okay. Okay.
in all the nodes, and so I just note these are all the key points which should
Mm-hmm.
take care. It's an open source platform for managing containerized applications, and it it manages a very high available cluster of computers. So what it means is, uh, in future we'll see like whenever the one
Mm-hmm.
computer, one machine node goes down, Kubernetes
Okay.
automatically restarts that container, or it restarts that node itself. So I mean, we don't have to manually do anything. Kubernetes will take care of that. So that is called, this is what like an intelligence system. Like
Artificial
Kubernetes
intelligence
is more
system.
like an intelligence
Yeah, that
system
you have
to under
mentioned.
who
Yes.
understand.
Okay.
Yeah. So so it understands like what how. So that is called, that is the
Okay.
reason it is called high available
All right.
cluster, highly available cluster. And as I said, like Kubernetes Master, it exposes some APIs so that these containers can run on the worker node. So everything in Kubernetes is REST API. So the Kubernetes master talks with the nodes using
Okay.
using APIs. So, and actually, as we discussed, like worker nodes are
Mm-hmm.
responsible for running the containers. So which is our program, and we need to have a Docker and a Kubelet. So I don't think so you will have any questions here because it's a very straightforward. But I thought of still going through. It's these
Yeah.
terminologies
Yeah.
we should be
Yeah.
knowing about.
Okay. Yeah. Okay.
So
Okay.
uh, yeah. So now we'll talk about. But still, if you have any
So
questions,
what is
you
a
can stop me, man. Yeah.
so what do you call as worker node? Can you go back there?
Yeah. So worker node. So yeah. So let me go back to to the cluster. To that. No, this is. Yeah. So what is a worker node? So worker node. So basically, in any cluster, in any company, we will have
Yes.
like a one master node, and lot of worker, at least minimum of
So
one worker node. So
oh,
basically, it's
that's
like a
these are
master
okay.
slave architecture.
Worker node is
So
nothing but a physical hardware or a VM. Okay. 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 Okay.
yes. So it's a
Is there a
VM,
similar node in
whichever
Jenkins which runs
which
okay. Okay.
yeah. So the only thing is here I mean, you just once you have a Kubernetes i- system installed it's like a on your on those machines, so you don't care about those machines. It controls, Kubernetes controls
Okay.
that
Okay.
cluster, entire cluster
Okay.
automatically. So you don't have to, if it goes down,
Mm.
Kubernetes will restart it like that. So that is the reason it is called worker node. Why it is worker? Because those are the actual. See, if you see here the master node in this picture, it just manages
Uh-huh.
the cluster and and coordinates. But the Docker, the actual processing happens at
Okay.
this node, like at this worker node, one node, two node, two,
Work.
three. So these worker nodes actually does
Okay.
the
Okay. Okay.
processing. Yeah. So if you see here, like if you are doing a
Right.
performance testing of any application, so Kubernetes master will deploy those application whichever node is available. So it will deploy to that. It will master will decide
Mhm.
where to put that application. Okay, which is free. It is intelligent enough to understand, okay, which node is free and which can be used, or like partial, if like pose. So it can deploy these. The application
Okay.
partially into one node and
Okay.
partially into another node, like that it can deploy. So this
Okay.
is why it is
Okay.
called intelligence system actually. So basically it coordinates. So when you do performance testing, it will run though it will split
Okay.
those
Okay.
traffic
Okay.
into all these nodes, and then once the testing is over, it will
Mhm.
collate all the data from all these nodes and give you a final report. What is the like how does the application performed
Okay.
in through two nodes or three nodes. So and with lot of traffic, how the application performed, like
Okay.
did it auto scaled or not, or did
Mhm.
the container was restarting a lot while. So like all those things, it will give you a report
Okay.
in the Grafana, or whatever.
Okay.
So other tools. And what else? We need Docker. Okay, in worker nodes, we definitely need
Okay.
Docker and Kubelet
So
for
why do we
sure.
need Docker in a node?
Um, and We need Docker in a node because the Kubernetes, all these
Mm-hmm.
apps, right? Containerized apps.
Mm-hmm.
These are, if you see on the top, so it can be executed only via like a command, like I mean, because they have built like this. They have Kubernetes is like Docker is a must for Kubernetes structure. So to execute the code, basically, when we say that this is a host independent, like it doesn't cares about the host. Like suppose you build
Uh-huh.
suppose you build your application
Right. Uh-huh.
service in Windows, okay, and you push it into the
Yeah, yeah, yeah.
you containerize your application, okay, and you don't हाँ बेटा जल्दी जाओ just a moment I'm
Yeah, yeah,
just
no
coming
problem. Yeah, yeah, yeah.
Rishan
Yeah, yeah, yeah,
needs
yeah.
to be yeah more give me a moment yeah suppose you install you
Mm-hmm.
developed your application into Docker in uh, your Windows machine and then you just containerized your application. Basically, you have some bunch of commands like Linux commands are there. You do Docker build, you do Docker run. So once your Docker is built, so now it can run in any part of the world, in any machine, Linux machine, Windows machine. Though you developed in Windows machine, it will execute. It will be get executed at the
Okay.
even at the Linux machines. So because it is decoupled from the
Mm-hmm.
so with that being said, so that is the reason it
Mm-hmm.
provides a platform independency, so you
Dependency.
don't worry about the host OS, yeah,
Okay.
so the dependency is removed from so that is the reason
Mm-hmm.
the Kubernetes has chosen Docker for to execute those containers which we have been built in any of the machines, but it is means how it maintains independence. So that is the reason
Okay. Okay.
they use
Mm-hmm.
Docker. Docker, yeah.
Um,
Any more
no,
questions?
nothing for now.
Okay, okay.
Yeah.
Kubelet we discussed. Yeah. So let us see. Now this is declarative configuration. Like what is it and
Okay.
why we need a declarative configuration. Uh, so basically. Now we will see like how these containerized
Uh-huh.
apps which we have developed basically how they are
Okay.
deployed and managed at Kubernetes. And so basically first we have to describe the
Mm-hmm.
desired state. So basically you want your application to I mean you want your Kubernetes cluster to be defined in such to maintain a particular
Mm-hmm.
state for your application. Suppose you want two nodes always be
Uh-huh.
available for your application. So how you do that? So you can describe that behavior
Okay.
into the YAML file. And once you describe that once you described your
Uh-huh.
characteristics into the YAML file, Kubernetes will make sure that those state is all that is your desired state. Suppose you say that you need your application needs always two nodes for sure, always. So Kubernetes will make sure even in production or in I mean of course in production it will always maintain
Okay.
two nodes for sure. So, I mean, that is the intelligence of Kubernetes. So, I mean, so we don't need a separate engineer to look into. Okay, like traditionally, we have to one engineer has to keep on looking into. Okay, these are the number of machines we should be available always. But with this thing, Kubernetes API server will take care of those things. So that is the reason this is called declarative programming, declarative configuration. Now,
No, no, no. Why are
YAML,
you
why
saying
YAML? Why YAML is,
how will
yeah.
Kubernetes handle it? You say how I didn't get the point. So
Say again,
you're saying
how?
engineer doesn't have to look into it.
Yes. So engineer doesn't have to. I mean, engineer has to look into it, but I mean, when I say like, I mean, engineer doesn't have to keep on looking. Okay, that the desired state. I mean, whether the VMs are up or not, like that. Those things he don't have to worry, because Kubernetes will make sure that there are always two nodes available for the network, for the
How is it
application.
getting managed? I
Your app,
mean, do we need to do configuration
yes,
or okay?
yes, yes, yes. So for that, we need to define
Okay.
it in the YAML file. Okay. So so that is what our next
Okay.
slide comes into picture. So basically, of course, there is a JSON file as well, but Kubernetes prefers YAML because it is much more
Uh-huh.
user friendly
Okay.
than JSON file than JSON. So to maintain the desired state. So our end goal is to have a two nodes
Mhm.
availability always for the application. So Kubernetes will make sure
Mhm.
Kubernetes API server will make
Okay.
sure that there are two nodes always. So what we have to do,
Mhm.
how we have to do is basically, I mean, first of all, this desired state is a very important concept in the Kubernetes because Kubernetes uses these objects for like YAML file, these YAML file is
Mhm.
an object for the Kubernetes. So Kubernetes uses
Uh-huh.
this particular YAML file
Okay.
to maintain the desired state. Okay, so basically you write a YAML file here,
Uh-huh.
like as you mentioned in this diagram, and then you deploy it to the
Okay.
Kubernetes API server. Okay, and when you deploy it, I mean that then your Kubernetes API server will make sure that your network always have two nodes available for your application. So
So is
this
it
is
more
the
of like
beauty of
a
Kubernetes.
load balancing wherein one node stays off and the other node is primary and the second node is secondary and the primary one is active, and if the
Yes,
primary one goes down, it will turn on the secondary one.
I mean, it will. I mean, suppose imagine like in
Right.
an enterprise there are a lot of applications, we will have like lot of agent nodes available. Like we will be having lot of work,
Mhm.
VMs which are up and running, but some VMs might be ideal at
Okay.
that time at a particular instance. Now, Kubernetes, what it will do for this particular app, it knows, okay, from this particular, from some other, I mean, it has a group of nodes, it has a group of VMs. Now, it will make sure that, okay, this node has gone down, so it will share some other node from some other thing I mean, which because we have a one master. Like for example, for in your company, you have one
Okay.
entire network, but there are so many applications, for your particular project, like you have like suppose 10 nodes, and you have one master server. Now out of those 10 nodes, two nodes, I mean, the sub project says, okay, I need two nodes. Another project says I need three nodes.
Mhm.
So another project says I need two nodes. So that's the way you define your YAML. But Kubernetes internally will make sure, okay, whenever suppose any as
Uh-huh.
defined in your YAML file, you need two nodes. So it will make sure that, okay, if one goes down, it will take from some other project, and it will for the timing,
Okay.
it will spin up, and it will spin up, and then it will it will bring down as well. So basically, most of the companies are using nowadays AWS machines, and or whatever
Uh-huh.
cloud, GCP, whatever it is. So what it will do is, it will spin up. So suppose
Mhm.
if request comes, it will spin up a machine, and then it will spin down as well, so that the cost
Yeah, yeah, I
so
told
that
you.
the
Yeah.
cost doesn't goes
No,
up.
no.
So yeah,
You're saying
yeah,
we will define in
yeah,
the YAML file.
in the YAML file.
Are we
Yeah.
defining the worker node configuration, or are we talking about
No, we don't have to define anything, we don't have to define any configuration. We'll see later. I mean,
Okay.
we'll see a YAML
No,
file
no.
as well,
Yeah, yeah. Okay.
and we'll see
Okay.
like
I
what
didn't
we
get
actually,
one
yeah.
point, which is the when you said
Hmm.
the Kubernetes will take care of when it is powered down. So is it more of like a
Hmm.
load balancing or switching if one node is uh,
Yes, yes. So actually, this load balancing thing is done
okay,
by the
okay,
Kubernetes master node actually. So we don't have to specifically like a define a load balancer here, because this load balancing will be done intrinsically by the
okay,
Kubernetes API
okay,
server.
okay.
Yeah. So if you see in the previous node, in the previous diagram, in the previous nodes here, so like it will, this load balancing will be done like as we mentioned about the performance testing of our application. So the load balancing will be taken care of by the Kubernetes master. We don't have to, we don't that load balancing will not, I mean, we don't have to specifically define that. That is the reason, I mean, I said like this is a declarative configuration. Like you declare, you are like a boss, like you are like a boss,
Mhm.
and Kubernetes master is like an employee. So you give your configuration like like Kubernetes is like a smart employee. Okay, you say, okay, I need two machines to be available for two nodes to be available for my application always. Now, this is the responsibility of Kubernetes to make sure that this is available
Okay,
always to
okay,
this for this particular
okay,
app
okay.
for your project. That is the reason. I mean, that is the reason it is called intelligent system, because we don't
Mm-hmm.
have to take care about the load balancing part or the traffic configuration part. Like that will be taken care by
Okay,
the Kubernetes API servers. So we don't have to like the we don't that is actually that is the work of a Kubernetes master node. So that will take
okay,
care of
okay, okay.
that scenario, that load balancing scenario. Yeah. So you as a boss, you have to describe your state. What is the state you desire? That is what it's mentioned here.
Mm-hmm.
So we'll see in the next slides. So I mean, yeah, YAML is much user friendly. We talked about it, and
Mm-hmm.
we talked about the desired state, and also yeah. So Kubernetes. Basically, Kubernetes controls this entire process with something called as controllers.
Mm-hmm.
So these controllers, they work to make the cluster current state match the desired state. So at one, see what happens is, I mean,
Mm-hmm.
this cluster might get down. Okay, so I mean, if you see here, sometimes you will see that okay, your nodes are restarting. Your nodes, you define six nodes for your machine, for your application, but you are saying you saw
Okay.
two nodes got down. But I mean, but what happens is Kubernetes will keep on trying to match the desired state. You mentioned
Okay.
about six machines. So how does it how does it do that? It
Okay.
uses a daemon process called controllers. I mean, controllers are the processes which makes the current state of the cluster to
Mm-hmm.
match the desired state of the cluster. So that is the basically these controllers, they work to make the, so that's what I said, like, so these controllers processes will make sure that okay, that the
In
desired
each
state is
cluster.
reached always, yeah, in each cluster. And so basically it's like a non-terminating loop. So basically it
Mm-hmm.
always watches your system. I mean, these controller programs, they
Okay.
always watch your system throughout day and night,
Okay.
365 days a year. And it's like they keep on polling these nodes, like
Mm-hmm.
whenever these nodes go down, so these controllers will make sure that okay, to spin up a new machine like this. So that's the, it's like a non-terminating loop. it, it
Uh-huh.
never
Uh-huh.
it never stops.
Okay.
So yeah, so yeah, as I said, like
It's more of a like a process
it's
that runs in the. Okay. Okay.
it
Okay.
basically it yeah. So it's continuously watching the current state, like what is your current state
Mm-hmm.
and what you desired for. So and how does it do? I mean, these controller programs, they run at background.
Okay.
So via the API server. Suppose examples would be like restarting the containers that died. Sometimes, like in the performance testing, what happens is like the container itself gets
Uh-huh.
died because of low memory or something like that. So because too much traffic
Mm-hmm.
has been sent to that container, and that container got died. So, so what happens is like, or you want to do a scaling of your
Okay.
application, like you want your application to scale up. So basically, the goal is to move
Mm-hmm.
from the current state to the desired state. So you have asked for like you have asked that okay, you should always have a six, you should always have your
Mm-hmm.
six nodes available. But you see, if you see here, the containers are restarting. So what it will keep on watching via API server. It will keep
Uh-huh.
on watching at your current state, and it will try to scale up the number of, basically it will try to scale up the
Mm-hmm.
replicas of the application. So so that's what it does. That's what it is saying here
Okay.
in this slide actually. And what is that? Yeah, so Kubernetes is very popularly
Uh-huh.
known as like a self-healing system. So that is the reason with
Mm-hmm.
this API, with these controller programs, it does this self-healing. So that is a very
Okay.
popular thing for Kubernetes. And and yeah, I mean, you don't have to worry like so as I mentioned before, like what is a declarative configuration? Like how does it differ from the traditional
Mm-hmm.
configuration method? So
Mm-hmm.
basically, you do not define any actions. So basically, you don't, as you said, like you don't, you are saying about worker node definition or etc. So we don't worry. I mean, as an engineer or
Mm-hmm.
as a application developer, we don't worry about such as you want to run a container or B container. We don't worry about all. I mean, we
Mm-hmm.
don't define all those detailed steps. As I mentioned, Kubernetes is like that smart employee. You as a boss, you say, okay, I need this. I need these many containers to run at these many nodes. You and Kubernetes will take care of those steps. Like you don't have to define any detailed steps like. What is the worker node configuration you
Okay.
need to do that you don't have to do
Mm-hmm.
that with Kubernetes. So the same thing like okay, it's like the same thing. You are like a boss, and you don't still. So basically, you don't tell smart people like you, right? What exact steps they need to do. You
Mm-hmm.
give them then end objective,
Mm-hmm.
okay, and then you give them the freedom. So they will, I mean, the communities will reach the desired state. How the app should be running, how many replicas are needed. So so basically, you just define
Mm-hmm.
those replicas in the YAML
Okay.
file, and you are done. I mean, yeah, how many replicas you need, you just
Okay.
define it in the YAML file, and then you are done. We'll see one example here, like one Nginx YAML file. So this is like a this the kind of the kind of YAML. This is a plain YAML file. We are just writing
Uh-huh.
it. We are uh, we are not saying, so what you are so traditionally what network engineers they have to like do like
Mm-hmm.
create or delete action on servers by like do SSH and
Right.
then run several CLI commands and do some approach. So all those are like imperative, that is popularly called
Okay.
as imperative approach of management. So in which we specify all the series of PowerShell commands or
Uh-huh.
any other Linux commands we mention it. But this declarative style of uh, configuration, here we do, I mean, here we just mention about what kind of
Mm-hmm.
pod it is. You give the name, like this is Nginx container name, and you specify the image. So this is the image or which, so the image
Okay.
is nothing but a Docker image. So basically this is your container, and you want to
Mm-hmm.
this container to run on
Mm-hmm.
this port. port number 80, and you have given a name, and you have given an API. So as I said, like in before, like in Kubernetes API structure, everything is REST APIs. So you mentioned about here V1 or V2 or V3 or whatever, but here right now it's V1 because we are
Mm.
using the V1 version of YAML file. And so you have to write, you have to be very much specific about these tags, because these are
Okay.
all predefined tags. And you can,
Mm-hmm.
but this image, this is your
We use a
image. I mean,
different
you can
version of
change it.
image. Okay, got it.
You can build your own image. Yeah, yeah. So you suppose you
Use
use a
the
Gatling
Nginx.
image here.
Okay.
Yeah, like you create a yeah, instead of Nginx, you create
Okay.
a Gatling image and you put it here. You write it here, and your application will scale up according to you just do this. I mean, this is your job. Like you write a YAML file and then you just push it
Okay.
to the Kubernetes API server. So like this. So Kubernetes like represents
Great.
everything as a RESTful
Okay.
resource called as Kubernetes API object. So you
Mm-hmm.
define a YAML file here
Mm-hmm.
and you deploy it in the
Mm-hmm.
cluster. Then your job is done. And so if you see here, it represents an API, which is an API
Okay.
object of kind pod.
So you can mention which cluster
So this is
you want that to get
so
updated or deployed or updated. Okay.
yes, yes. So so the resource type is you I mean yeah. So if you specify the resource type, this is the resource type is pod. So the Kubernetes will figure out like what type of resource it needs to create, update, or delete for this. For you just say that, okay, what
Mm-hmm.
is the kind of this? This is a pod. So the Kubernetes
Mm-hmm.
will make sure, okay, what it needs to you just mention it. It's a pod. That's it.
Okay.
So this is one example. And yeah. So if suppose how do you create a pod? So basically,
Uh-huh.
you create a file,
Uh-huh.
you create a YAML file, and then you send this file
Okay.
to the Kubernetes API server. And when you declare it, you want all the containers. So like we have like Nginx container, so we want
Mm-hmm.
all the containers to be up and running always. But because for some reason the Nginx got crashes due to program fault, or
Mm-hmm.
ran out of memory for some reason, then Kubernetes will perform the necessary actions like killing of the
Mm-hmm.
container and restarting the container, or moving it to a different node, as we discussed before, like it from another of your project, like it will share a node from that project, or it will
Mm-hmm.
spin up a new machine into the AWS. So Kubernetes will keep on doing that, but traditionally we have to ask engineers, okay, can you please restart the VM, or can you do, can you? I'm seeing some issues at my application. But now with this
Mm-hmm.
approach, so Kubernetes will perform the action like creation,
Mm-hmm.
updation, deletion of the container. It will it will take care
Okay.
of
Okay.
all those stuff actually. So yeah. And yeah,
So
that's
what
pretty
is a
much it.
Kubernetes API
So
server? Is
mm,
it do you mean what does that mean? Is it a master or is it the
yeah,